Hi everyone, welcome back. Today we're going to be looking at standard 6.ee.b5. Understand solving an equation or inequality as a process of answering a question. Our vocabulary: equation, the result when an equal sign is placed between two expressions. Solution, a number when substituted for the variable makes the equation true. Inverse operations, operations that undo each other like addition and subtraction. Here we're using a scale to represent balancing our equation. So if you notice, on one side of the scale, we have the expression 3x plus 2, and on the other side, we have the number 5. So whatever the value of x is, this expression must be equal to 5 to keep the scale balanced. If we were to perform an operation on one side of the equation, we have to do it on the other side, again, to maintain our balance. So here we're using fruits to represent apples, right? So if I have 3 apples on this side of the scale, in order to maintain the balance of the scale, I would need to add 3 apples of equal weight to ensure that the scale remains balanced. And that's what we do with our inverse operation. So we would take 3 from one side. We also need to take 3 from the other side. To solve one-step equations, we need to ask ourselves these questions. What is the variable? What operation is performed on that variable? And what is the inverse operation? So if we are dealing with addition, the inverse will be subtraction. And if we're dealing with subtraction, the inverse is addition. If we're dealing with multiplication, the inverse is division. And for division, the inverse is multiplication. If we're squaring a number, the inverse is to take the square root. And if we're taking the square root, the inverse is to square it. So for this lesson, we're going to focus solely on addition and subtraction. So when we're looking at our first example, I want to ask myself those questions. What is my variable? My variable is m. What is happening to my variable? I'm adding 9 to that variable. What is the inverse of adding a number? The inverse would be subtracting a number. So we're going to subtract 9 on both sides of the equal sign. And the reason why we drew this line here is to ensure that when we're performing our operation, it's happening on both sides of the equal sign. Now, if I have a positive 9 and a negative 9, that's like if I have $9 and I give away $9, what do I have left? I have 0. So in this case, we don't have to write the 0. You can if you want to, but anything plus 0 is just itself. So what we can do is just say that cancels out and just write the variable. Now let's go ahead and perform our operation. So we have 3 minus 9. Now our integer rule tells us that if we are working with opposite signs, then we need to subtract and keep the sign of the larger number. So 3 minus 9, or 9 minus 3, is 6. And the sign is negative because the 9 is the larger number. Let's go ahead and perform a check by substituting the value of m back into the original equation. So negative 6 plus 9, we'll need that to be equal to 3. So here I have different signs. So I'm subtracting 9 minus 6 is 3. Keep the sign of the larger number, which is positive. So 3 is equal to 3. That equation is balanced, so my answer is correct. Let's take a look at the next example. Again, I'm going to draw my line. What is my variable? My variable is j. What's happening to my variable? I'm adding 3. What is the inverse of addition? To subtract. So I'm going to subtract 3 on both sides. This here cancels out because it becomes 0. I bring down my variable, and now I have to simplify the other side of my equation. Negative 1 minus 3, same signs. We're going to add and keep the sign, so that gives me a negative 4. Let's go ahead and perform our check. So we have negative 4 plus 3 is equal to negative 1. Negative 4, positive 3, we have different signs. Different signs we subtract and keep the sign of the larger number. So that's a negative 1 is equal to a negative 1. It's balanced, and that works. Let's go ahead and take a look at our third example. So again, I'm drawing my line to make sure that I have both sides of my equal sign. Now, if you notice that the order in which the addition is happening is a little bit different than the previous examples, but it's the same thing. Addition is commutative, so I could rewrite this if it makes my life easier as g plus 4, okay? But we're going to solve it just the way it's written. So here we have a positive 4. So just like in the previous example, the objective is to get that variable by itself. So we want to move away anything that's next to the variable. So I have a positive 4. That means I'm going to subtract 4 on both sides. This here cancels out. I'm going to bring down my g. Now I have same signs. I'm going to add and keep the sign. So 12 and 4 is 16, and my sign is negative. Let's go ahead and check our work. So I have 4 plus negative 16 is equal to negative 12. So here I have different signs, a positive 4 and a negative 16. So I'm going to subtract. 16 minus 4 is 12. Keep the sign of the larger number, which happens to be negative, so that's a negative 12, is equal to negative 12, and that is indeed balanced. Okay, so again, what is our objective? Our objective is to get the variable by itself. And how do we do that? We use inverse operations to move whatever number is next to it. So here we're adding 9, we're adding 3, we're adding 4. So we're using the inverse of addition, which is to subtract, to move that number. Let's go ahead and take a look at this next example. So I have 5 plus c. What is my variable? C. What is happening to the c? I'm adding 5. What's the inverse of addition? To subtract 5 on both sides. So that will cancel out. So now I have c is equal to 0 minus 5 is just a negative 5. And then we can perform our check. Why do we perform a check, you ask? Well, when we plug the numbers back in, it must make sense. It must ensure that our equation is indeed balanced. So if it's not balanced, then we know we made a mistake and we need to revisit what we completed. So 5 plus negative 5. So if I have $5, I give it away. That's just 0. 0 is equal to 0, so that is indeed balanced. So we're going to use the same strategy that we did with the previous 4 problems to solve these problems. The only difference is that instead of adding, we're now subtracting. So I'm going to draw my line just like I did before. Okay, what is my variable? F. What is happening to the variable? I'm subtracting 3. What's the inverse of subtraction? Add 3 on both sides. Okay, that cancels out. I bring down my F. Now I have a negative 5 plus 3. So here we have different signs. So we're going to subtract and keep the sign of the larger number. So 5 minus 3 is 2. The sign is negative. So F is equal to a negative 2. Let's plug it back in. Negative 2 minus 3 is equal to negative 5. Same signs, add and keep the sign. So that's 5 and the sign is negative. That is indeed balanced. Let's take a look at the next example. So again, this is a place where it's good to pause the video, try the problems on your own, and then come back to see if you got it correct. The variable is n, we're subtracting 18. The inverse is to add 18 on both sides. Negative 18 and a positive 18 cancels out. N is equal to 20. Now we substitute it back in for our check. So 20 minus 18 is equal to 2. 20 minus 18 is 2. And that is indeed balanced. G minus 8 is equal to negative 2. The variable is g. We're subtracting 8. The inverse of subtraction is to add 8 on both sides. That cancels out. We bring down our g is equal to. Now we have negative 2 plus 8. Different signs subtract. That gives us a 6. And that's a positive 6. Let's go ahead and substitute to check our work. So 6 minus 8 is equal to negative 2. 6 minus 8 is a negative 2, which is equal to negative 2. And that is indeed balanced. Let's look at our next example. Our variable is m. We're subtracting 11. The inverse of subtraction is to add 11 on both sides. That cancels out. 13 plus 11 is 24. Now we can go ahead and check our work. So we have 24 minus 11 equals 13. 24 minus 11 is 13. So here it is balanced. Okay. Again, try these problems on your own, then go back and check your answers against the work that I completed. Thank you for watching and have a great day.